The last task is related to the HVDC analysis. You have an HVDC, the converter, voltage source converter, that is connected to transformer and then to a grid. So according to the text, you have a transformer that is 400 kilovolt here, 230 kilovolt here. The voltage AC is 405 kilovolt. This voltage of VSC is 235 kilovolt, and you have the reactance. This one is 4 ohm. The reactance of transformer is 3.8. Okay, and the phase difference between these two voltages are approximately 10 degrees, and the task asks for the active power, reactive power, and the limitation of the HVAC. We can talk about it. So let's solve them. So first you have to know that this voltage is on the right side of transformer. Suppose that you want to calculate the whole system on the left side, you have to convert this voltage to the other side. It means that you have to convert to a 405 times 330 over 400. This one will be the voltage will be here. Okay. So according to your PowerPoint, you know that if you have a HVDC line between the voltage converter and the grid, we have a reactance, two reactants. Some of them, suppose that as an X, the whole power, active and reactive power that pass through this reactance will be calculated by these formulas. This one is active power, this one is reactive power. Suppose that if you have the voltage of VSC here and the voltage of the grid and the phase angle between them, you can use, and the reactance between, you can use this formula to calculate active and reactive power. In the system we have here, so this one is the power system you have. Voltage source here, two reactances, and the voltage of grid. The sum of two reactants will be this one, 7.8. And the phase angle between these two voltages are approximately 10 degrees. The voltage source, the voltage of VSC is 235 kilovolt, and the voltage of AC is 232. And that one I calculated before. You have to convert from the right side of transformer to the left side of transformer. When you have all of these parameters, you can use this formula to calculate the active power that passing through this way. The amplitude of voltage source, VSC, the amplitude of voltage of grid divided by the reactance, whole reactance, and the sign, the phase angle difference between two voltages. And if you use this formula, this one is the active power. And the reactive power, you can use this formula, the same as before, but the amplitude and the phase shift between two voltages. If you use this formula, you can calculate the reactive power passing through this way. Okay, the last part of this task asks for the 3 limitation of the high voltage AC system. And I got this from your PowerPoint, the course you had. The limitation you have for the AC, you can use this description if you have this type of task in your exam. But you have to know that there is the main limitation is related to the distance of the high voltage AC. If you increase the, according to this formula, if you have a transmission line, AC, V1 is here, V2 is here. If you increase the length of this transmission line, the whole X, the whole reactance of transmission line will increase. So this one is the positive, is the maximum active power that the transmission line can send to the other side. So according to this curve, P delta. So if you increase the reactance, this peak will decrease. So with a long transmission line, so the whole power can you send from one side to another side will decrease. It's one limitation. The compensation, when you have a long transmission line, this one is the reactance, and we have we need to compensate the reactive power that you have here. So the compensation and the capacitor you have as well. So the need for compensation is another challenge for the for the long transmission line, specifically for the cable, because the capacitor of cable is very high and the reactive power produced by the capacitor is very high. You need to compensate. The next is asynchronous connection. Anyway, suppose that if you have 2 power system in 50 hertz, another one is in 60 hertz. You cannot connect them with the high voltage AC. You need HVDC to connect 2 power system in a different frequency. And the last one, the large power system oscillation from one power system will be sent to another power system. So since if you have HVAC, but with the HVDC, you can decouple 2 power system. That if you have a disturbance in one system, the other system will be safe.